you know, people haven't asked a ton of questions, partly because there aren't any people here. So we have time to stretch out a little. And so before I get into the next stuff, I was always planning to have full solutions for everything, but then I've gotten behind on that. So I thought we should spend a couple days just going back, work through some problems, some of the daily problems that aren't solutions for, and just talk about some of that kind of stuff. And then if you have any homework questions, I can answer any homework questions too. So I was going to today do conservation of mass and control volume stuff. All right, so I'm going to start with conservation of mass number 2. So the idea is there's this water storage tank. Everything's given in gallons. So it starts with 100,000 gallons of water. Every day, 10,000 gallons is used. And water's added at this daily rate of 5,000 e to the negative t over 20. And that's all in gallons, and t is in days. So we can do it all in days with that as the unit of time. And the question is, how many days is this thing going to contain water? So we're basically just looking for where it gets to 0. Okay, so it starts out with, okay, so this is conservation of mass number 2. You remember this one? Vaguely, maybe as we go. Yeah. Okay, so it's in gallons. I am going to convert gallons to cubic meters, but notice that if you have dm dt is equal to m dot in minus m dot exit, you can write that as density times, d volumetric flow rate dt is equal to density times the volume rate in minus density times the volume rate out. And all those densities just cancel. So you can do this all in terms of volume for a liquid. You can't do it that way for a gas because the densities will be different at different times. You know what I mean? But for a liquid, you can do that because it's basically incompressible. So this tank starts with 100,000 gallons, and that's equal to 378.54 cubic meters. Cubic. The average usage per day is 10,000. So 10,000 gallons per day. That's out, and that's 37.85 cubic meters, per day. That's leaving. And then it's added at an average rate of 5,000 e to the minus t over 20. That's also in gallons. I didn't convert that. So 5,000 gallons in cubic meters is 22.73. Didn't we just do 10,000 and it was less than twice that? That is odd. Okay, well, so 4, 5, 4, 6. Okay, so these numbers, I guess, are wrong. So 100,000 gallons is 454. 0.6 cubic meters. 10,000 gallons a day is 45.46. And it's added at a rate of 22.73 e to the minus t over 20. And that's in meters cubed, and the time is in days. So how many days until this tank is empty? So this is the start volume. And you know, our conservation of mass equation says dm dt for the control volume is equal to m dot coming in minus m dot going out. I'm going to divide off the densities, and we end up with, so you can think of it as ddt of the volume in the control volume is equal to what's added, 22.73 e to the minus t over 20, minus what's going out, 45.46. Well, this is just, I still have it all in the differential form. So this is all just rates. like per time unit. And now I'm going to integrate everything, and I'll get that the change in the volume is equal to 22.73 e to the minus t over 20 minus 45.46 all times dt. And now integrate that. I guess this should still be d. And now we can integrate both of those sides. And you get that the change in the volume is, so now if you integrate this, you get, I should have brought a calculator. Could you multiply 20 times 22 point, I guess I can do that. That's 454.6, 20 times this. So negative 454.6 times the integral of e to the u. I just did that u substitution. Minus the integral of 45.46 dt. Are you with me on this? And so now you can integrate, substitute back in, and you get negative 454.6 e to the negative t over 20 minus the integral of this times the change in time. And so that's just 45.46. We can write that as t if we think of time 0 as being 0. Well, we are asking when this tank is going to be empty. So our final volume is going to be 0. Our starting volume is 454.6. So our change in volume is negative 454.6. And that's equal to negative 454.6 e to the minus t over 20 minus 45.46 t. Let's see. So where are we? This is coming in. This is going out. And so now we can just find like the 0 of this function, which I had, but my numbers were wrong. Okay, so I'm just going to enter this function So negative 454.6 times e to that thing. And then minus 45.46 t. And then plus 454.6. That's 0, that's... Okay, so we should have, let's see. Something went wrong there. Okay, so the change in the mass is equal to the rate of mass coming in minus the rate of mass going out, and we're doing it all by volume. So ddt of the volume is equal to the mass coming out is 10,000 gallons a day. That's that. Added is this. Oh, it must be it's a constant of integration thing, I think. Because, well, let's see. So now I'm integrating. You don't see anything, do you?
It's the integration thing.
Yeah.
I'm rusty. Yeah.
Okay, let's see. Let's think about it. So this part is good though, right? This part. So this part's good. And then we can integrate both sides. So and now, okay, so let me just be more careful with my constants. All right, so we integrate this. And so all of these are going to be from S1 to S2. S1 to S2. A U substitution for this, so if I go U is equal to negative T over 20. The UDT is negative 120. So dt is negative 20 du. Um, hmm. Well, let me think through it again real quick. So this U substitution, this comes out to be the integral from state 1 to state 2. And negative 20 times this was, what was that, 454.6 negative. This is always like when this kind of thing gets screwed up with my screen, like right when I am like all flustered. So e to the u du. Okay, so now this is going to be the volume evaluated from S1 to S2 is equal to negative 454.6 e to the u evaluated from state 1 to state 2 minus 45.46 t evaluated from state 1 to state 2. And so the volume is going to be negative, state 2 is 0, state 1 is positive 454.6. This is, I'm going to rewrite this as 454.6 e to the u, e to the negative t over 20. And this is evaluated from time equals 0 to time t. Minus 45.46 evaluated from time equals 0 to t, so I can just leave that as t. And I think maybe this is the problem here, that I wasn't taking into account the subtracting the 0, so you have negative 454.6 is equal to negative 454.6 e to the negative t over 20 minus, this thing evaluated at time equals 0. So that's e to the 0, which is just 1. Minus 45.46 t.